Welcome back everyone. This particular video is a follow-up to my last video which covered off setting up a basic telemetry sensor. And in that particular video we showed you how to set up a basic voltage sensor and set up some alarms, some visual alarms for the screen as well as an audible alarm. Now, just to recap, I've got a power supply set up to the voltage sensor. You can see the current live reading, which is 10 volts. If I vary the power supply, we can vary the voltage around a bit. And just to recap, as far as the alarm settings were concerned, I'll just go into the alarm settings. If you recall from the last video, we had a low voltage alarm set to 6 volts, medium voltage alarm or medium low voltage alarm set to 8 volts, and then a high alarm set to 12 volts and an extremely high or critical voltage high set to 14 volts for this particular example. And I also showed you how to set up an audible alert. So you can set up audible alerts for all the trigger points, but in this particular case we just set up one for the example. And obviously when we reach the 14 volt trigger point, these spoken words, critical voltage, are spoken.
Critical voltage.
Just like that. So I'll just go back to the main screen. I'll just vary the power supply just to show everybody again, on a recap from the last video. So we get to 12 volts, we should get a yellow warning triangle, but no audio. And then if I go further on the power supply and increase it to 14 volts, we should hear the audio being spoken, as well as the triangle should change colour to a red, indicating like a critical condition.
Critical voltage.
There you go. Now you might notice if we were flying around, and this could be a low voltage, in this particular example we're just using a high as an example, you'll notice the audible alarm has only sounded once, yet we do have a permanent alarm condition as defined by the red warning triangle. If I drop the voltage below the trigger point, which is 14 volts, you'll notice the warning triangle now changes colour to yellow. And if I increase it back up again,
critical voltage,
we get the audible alarm again, as well as the red triangle. So the audio only triggers when you cross the threshold. So as we increase,
critical voltage,
and it only goes off once. And that can be useful in a lot of situations where you don't want too many alarms going off. However, in some cases, if you have a really dire situation, a very critical situation, you may want to have the audible alarm continuously sounding. So this video will show you how to set that up. And basically we need to invoke another menu within the PowerBox transmitter, and that's called Telemetry Controls. The Telemetry Controls, bit of a tongue twister, allows us a lot more flexibility with what we do with the telemetry data. Okay, so I'll just reduce that back to about the nominal voltage which we'd played with before, around about 10 volts. I'll just clear the alarm. And now we'll go into the Telemetry Control menu. So from the main screen, swipe down, go into the main menu structure, scroll up, and this is the one we want here, Telemetry Controls. So we'll just go into there, and at the moment you'll see there's no telemetry control defined. We're going to set one up. So here we go, telemetry control. We can rename this, and it's a good idea to rename it only because you can reference this later for logic switches, etc. What shall we call it? Let's say, I don't know, let's say audio. Just trying to think what we'll call it, just for this particular example anyway. You can call it whatever you like. Let's call it, I don't know, audio repeat. Now, it'll ask us for a source. So this is the telemetry source we're going to use for this particular telemetry control. So in this case, we're going to use the voltage sensor, which is the PBS V60. So select that. We select the value that we're going to use, and in this case the V60 only offers us voltage sensing. Click on OK, or press on OK, and you'll see at the moment it shows us 10.1 volts. If I move the power supply, you can see that changing. So that's a live input voltage at the moment. So that's what the sensor is actually currently reading. And there's this output indicator. So this is what we're going to play with. So we go into the output and you'll notice it changes to this more complicated screen. Okay, on the left hand side in this blue box, if you see some weird wiggly lines within the colours and that's just my camera. It's not the screen on the core. The screen's quite clear. So those lines and that are just moire patterns generated by the sampling speed of my camera. So we see there PBS V60 voltage 10.1 volts. Again, that's our live voltage. So if I fiddle around with the power supply, you can see that going down. Whatever you like to say, it's moving. And just above it, we have an FS 0 volts. So in the case of a fail-safe condition, so the FS is for fail-safe. If for whatever reason our receiver goes into fail-safe, what it does, it substitutes the actual voltage at the time with a voltage that you preset. So this is like a safety mechanism. So for instance, you might have this set up with air pressure on your retracts. If the air pressure drops between a particular value, it automatically deploys the retracts. You can set a fail-safe value here. So if for whatever reason the receiver goes into fail-safe, or you have a fail-safe condition, it'll substitute the actual real-time voltage with a fail-safe value voltage of whatever you like. So it might be the fact that maybe you want the retracts to deploy in a fail-safe condition. You would set the actual air pressure reading here to mimic a condition where the retracts would deploy automatically. So that's just for fail-safe. Just below the PBS voltage is Sim 0 volts. That's actually a simulation voltage. So PowerBox have cleverly included a simulation feature here. So we can actually edit this voltage. Now remember, we're using a voltage sensor, so this is actually voltage. If you're using a pressure sensor, the units would be in pressure, temperature, etc., etc. And we can play around with this voltage here, so we can actually adjust it. And what happens here is we're simulating the voltage, the real-time voltage, with this simulation control. So you don't need to actually vary the voltage in your aircraft to play around to see what happens to the output. This is actually quite clever because it's a very handy feature to have, especially when setting it up, and you want to make sure that the output is correct for your chosen values. Okay, so a lot of people get confused with this telemetry control function. It's not that difficult. It's actually fairly simple. Remember in the previous video we had set 10 volts up as our nominal voltage. So we'll use 10 volts again as our nominal voltage. Now at the output here, so this box here is basically our output. So remember we called this control telemetry control audio repeat. So you notice it's set to 100% at the moment. So 100%, that's fine, but how do we get 100% from the 10 volts? Well, there's this limiter function here. So at the moment I haven't set these values, but let's play around with it, because if I play around with it, it might give you a better idea how all this works. So let's set this to say, I don't know, we'll set it to, just trying to think which way is easiest to make it self-explanatory. Maybe we'll set it to say 20 volts. (19) 20 volts, and we'll set the bottom one to say 0. Okay, so the limiter, this defines the range over which the control works. So basically at the moment we've set 0 to 20 or 0 to 20 volts, and the output will fall between this 0 and 20 volts. However, the output will vary between minus 100% all the way through 0 to plus 100%, similar to a servo output. So you have minus 100 all the way to plus 100. So in effect you have a range of 200%. Now, the limiter basically acts as a scaling function for the input voltage. So at the moment, we have about 10 volts going in. So 10 volts is halfway between 0 and 20 volts. So if you think about it as a servo travel range, you have minus 100 all the way to plus 100, and that's defined by this 0 and 20 volt range. So in other words, at 0 volts, it's equivalent to minus 100% travel, and 20 volts is equivalent to plus 100% travel. And 10 volts, which is currently what we're reading with the sensor, will give us roughly 0 or 1%. So let's try the simulation, because I can vary the voltage here on the power supply. And you'll notice the output here will vary as well as I vary the voltage. But because my power supply has got a very coarse adjustment, it's going to be easier just to use a simulation voltage here. So we'll click on simulation. And now we have 0 volts. And you'll notice the output is minus 100. So that's right at the end of its travel, if you like. We can reverse this just by hitting the inverse function. So you can go from plus 100 to minus 100, but we'll just leave that for normal for now. That's just a handy feature if you need to invert it for whatever reason. So our simulation voltage is currently 0 volts. So like I said before, let's go to say 5 volts. Now 5 volts is a quarter of the range between 0 and 20 volts. So if I go to 5 volts, I should just hold it down. There we go, 5 volts. Now, 5 volts is a quarter of 0 to 20, but if you think of it from a servo travel perspective, where you have minus 100 to plus 100% travel, it's actually negative 50% travel. So 5 volts equates to negative 50% travel. So far so good, hopefully. Now, let's increase the simulation voltage to say 10 volts. So remember this figure here is a simulation figure. 10 volts, we get 0% travel. In other words, mid-travel on the servo output if you like. And 10 volts is exactly in the middle between 0 and 20 volts. And obviously if we then increase it to say 15 volts, that should give us plus 15% travel. Plus 50% travel. And as you can see here, so that's 3/4 of the servo travel range if you're thinking in servo travel terms, between minus 100 to plus 100% travel. And then of course, if we adjust the simulation to 20 volts, this will give us 100% travel on the output from this control. So hopefully that sort of makes sense, because we're going to use that to set our trigger point for our audio. Now there's a couple of other boxes here. I won't go into too much detail at the moment, but here we can set up a switch. So basically you can flick a switch and you can define a certain percentage. So for instance, if you want to disable this control, you can flick a switch and disable it. You can also use logic switches, other inputs. It doesn't necessarily have to be a toggle switch as such to control this. Okay, so now remember for our example, we've got 10 volts on the voltage sensor. We want to make a useful range, so remember our critical alarm trigger point was 14 volts. So let me wind up the power supply to 14 volts.
Critical voltage.
Oh, there goes our current alarm. I should disable that for this example as well. So remember we're up about 14 volts. I might just disable that alarm so it doesn't keep going off. And we won't be using the audible alarm within this basic telemetry function because basically we're going to be using the telemetry control to set an audible alarm trigger for this critical 14 volt position. Cool. All right. Back to our telemetry control. Alright, so we're going to use 14 volts as our critical audio trigger. So basically, if our voltage goes above 14 volts, we want the audio to continuously sound some sort of warning. So how do we do that? Okay, I'll just wind it back down to around about a lower voltage below 14. We use this limiter here. We play a bit of a trick here. So what we're going to do is we'll set the top limiter value to say 14 volts. Now this is the trick here. The bottom value we're going to set up to 13.99. Sounds a bit odd at first, but you'll see why and how it all works in a second. So let's go 13.99. Okay, I might try the simulation here. It might be easier to show what's going to happen. So our simulation voltage, let's drop that. 20 volts is way too high. We want to go below 13.99. Okay, so we'll put in 13 volts. Now, at 13 volts, we're below the critical threshold, so we don't want any audible alarm at this stage. We can just rely on the previous visual alarms. You might have another audible alarm, just a single alarm set in the previous alarm screens. So 13 volts, you notice our output here is negative 100%. So say for instance we consider that an off position and we want plus 100 to be on. So what's going to happen is as we increase the voltage from 13 volts, as it gets to 13.99, you'll see it trigger. So you'll see this green line trigger to the 14. Once it triggers to the 14, this particular program will automatically snap this value to plus 100%. So let's give it a whirl. Let's see what happens. I'll just hold that down. So we've got 13.2, 13.4, 5, 6. I'll slow it down in a second. So as our voltage comes up, 13.99, let's see what happens when we go to 14. Bang. It's gone to 14 volts. So that's our trigger point. And you'll notice the output has gone to plus 100%. So if I reduce that by 0.01%, negative 100, plus 100. So setting these values so close to each other gives us that very little hysteresis. So basically it snaps over between negative 100 to plus 100. Because we don't want a linear value here, we just want either on or off, that's it. So this gives us a switch using the voltage parameter. So basically, as soon as we hit 14 volts, this audio repeat function will basically snap over to plus 100%, and we can use that to trigger an audible alert. So once we've set that up, if I go back a screen, you'll notice output is minus 100. So now we've gone out of the simulation. I'm going to go back to using the power supply now. Because we're out of the programming menu, it's gone back to monitoring the actual voltage coming from the sensor. So let's play around with the power supply. And if you look carefully, the output, we're above 14 volts, it's gone to 100%. If I drop it just below, it's a bit hard here on the power supply, but I'll just drop it just below 14. And lo and behold, the output's gone to minus 100. So basically this is acting as a simple switch. So you've got minus 100, plus 100. Nothing too complicated. It's easy when you know how. Okay, so how do we then use that for an audible alarm? Well, let's have a look. Let's go into voice settings. So when you go into the voice settings menu, if you haven't set anything up before, the default entry is for flight modes. And you can't disable this, you can turn it off. Currently it's actually off. However, this is used to play audible alerts for your flight modes, which pretty much everybody uses, or a lot of people use. You can't, like I said, you can't delete it, it's just a basic entry here. We're going to add our own entry, and on the left hand side we can select what do we as the audible alert. You can have your own text. You can actually speak the actual telemetry value. So for instance, if you've got a voltage sensor, you can actually say 10 volts or 14 volts. There's a short to medium option. You can play around with that. In this particular case, I'm going to use some text because I want my own text. So let's click on that. In this particular box, we enter the text. So remember the PowerBox radios have a text-to-speech conversion. software inbuilt, so we might make use of that. It's a lot easier than having radios which need MP3 files or WAV files, load them from your PC. This particular text-to-speech conversion software is actually quite good. Okay, what are we going to call it? I don't know, let's say critical voltage or critical flight pack. Yeah, let's say voltage. I'm not very inventive here. Oops. Voltage. And if we want to just quickly test that, we can just hit the play button.
Critical voltage.
Now we might not like the person, so you've got a choice here. Obviously you can change languages as well, but let's try, we can do Queen Elizabeth. No, let's try Karen.
Critical voltage.
Everybody likes Karen. Okay, now you notice here we've got a replay option. So you have one shot, so that basically if it's triggered it'll only say it once. However, we can also select time interval. So here's the trick. This is where you set the time interval. And there is a minimum setting. I think it's 2 seconds or 5 seconds. So 2 seconds. So if you want it to repeat every 2 seconds, select 2 seconds. Obviously, if you have a long text string, you might want to select the next option, 5 seconds. Depends, you may want to stretch it out even to 10 seconds. That's just a personal preference. Let's try 2 seconds. Okay. So now what's going to happen is every time this particular voice entry or text entry is triggered, it'll repeat itself every 2 seconds. So that's how we get the repeating audio. Now, the last thing we've got to do is activate what control we're going to use to trigger this voice or text input. So we go into the control menu, and here, this is where we select the control. And obviously we can select switches, yeah, pretty much whatever you like. Virtual switches, you have your toggle switches, you can even use your joysticks, your knobs, whatever. But we're going to use a telemetry value. And remember how we set up that telemetry control as audio repeat. So we'll select that and go OK. And here is where we set basically the range where we can operate control. Now, remember we're only setting a basic switch here, so we don't really have to do too much in the way of changing this. So green is on, red's off, and then you have a middle hysteresis. So this is really handy if you have a linear control. And this particular example with the voice activated switch, it's not linear, it's just going to be straight on and off. Actually, if I go back into that menu, if I move, now you won't be able to see it on the screen.
Critical voltage.
I've turned the power supply up,
Critical voltage.
and you'll notice the audio's gone off, and it'll keep repeating. And you'll notice the cursor, this little white cursor here, has gone into the green zone, in other words, the on zone. I'll turn it off by lowering the voltage on the power supply, and we're back down there again. So in this particular example, because we're only using it as a switch, you only have the cursor on the far left-hand side of the screen or the right-hand side of the screen. It'll never be in the middle or somewhere in between, because we've only, remember in the control we only set plus 100 and minus 100. So at the moment it's at minus 100, and then as I increase the power supply at some point it'll switch to plus 100, and that cursor will then jump over to the far right-hand side. Simple as that. Alright, let's go back to our main menu. So I'll just drop the voltage down to 10 volts. Now notice that the triangle's still flashing because we haven't changed the way the visual alarms work, or the visual cues, so they still work as per normal. And let's try it out. So we're flying around, we're at 10 volts, and for whatever reason the voltage creeps up, goes up to 12 volts, yellow triangle comes on. No audio, which is correct. Now when we get up to 14 volts, this time we will get a red triangle plus a recurring audible alarm.
Critical voltage. Critical voltage.
And
Critical
there you
voltage.
go.
Critical voltage.
Now if I reduce the voltage,
Critical voltage.
the audible alarm disappears. However, we still have the visual cues. So when you land and if the voltage returns back to normal, you still have a visual indication that there's something's gone wrong. And again, don't forget you have your min-max. If you double tap on the widget, you have your min-max values available to you as well. I'll just reset those. One thing I didn't cover off in the previous video was if we have multiple screens, I'll just add another screen here. So we've got, say, 2 screens. So this is page 2 of 2. Obviously, I don't have any widgets programmed into it, so it's blank. So you can scroll across. So say you're flying, you're on this screen, and you might have 5, 6, 7 screens with multiple widgets. Like, how do you keep track if there's an alarm comes up? How do you keep track of what's what? Well, there's another handy feature within the PowerBox transmitters. If I trigger an alarm, let me increase the voltage. Notice the screens actually jump back to 1. So whenever you get an alarm on the screen, it'll put that screen as your home screen temporarily when that alarm pops up. So if you land, you might find your main screen has changed to one of the other screens which has an alarm. So that's another good prompt for the pilot. Once they've landed, they can review their alarms, etc., etc. Okay, hopefully that's enough. Hopefully you found this video informative, and I'll talk to you all next time. Thank you.